Good morning, students. I would invite Prachi ma'am to start the session.
Hello everyone, how are you all? And very good morning to all. So I hope you all are doing well and enjoying your learning, right? So today in class we have Harika, Bhavna, Gayatri and Omkar. So just quickly mark your attendance in the chat by typing yes, good morning, whatever. And then we will start with a quick revision and then we will learn the new things, right? So I'll be sharing my screen. So I hope you all can see my screen, right? Okay. So I hope my screen is visible to everyone and my voice is also clear. So if my voice is not clear or if my screen is not visible, you can let me know in the chat, right? So here, we yesterday we started with the new topic that is the atomic structure, and in that we saw that what are the things that we are going to learn in the atomic structure. And there we saw that yes, we will be learning about the different models, and then we will learn about all the models in the details, and then we will learn about the other things too, and finally we will learn about the electronic configurations. That was the rough roadmap of what are the things that we will be learning. So we started with the atomic models, and in that we learned that there were four atomic models that we have to learn about, or that were given to explain the structure of atom. So the first model was given by the J.J. Thomson, who also discovered the electron. So once he discovered the electron when he was experimenting with the cathode ray tube, then after that he gave the model, and that model was also known as plum pudding model, raisin model, or the watermelon model. And what was the characteristics or the main points of that model? So he said that atom is a sphere and the positive charge is uniformly distributed. The positive charge is uniformly distributed and the mass of an atom is assumed to be uniformly distributed. And also he was able to explain the neutrality of the atom. So basically, his atom or the picture according to J.J. Thomson should be like we have the positive charge which is evenly distributed, and on to that we have the electrons. So it would look something like watermelon. But there were few drawbacks to his model, that he was not able to explain the stability of the atom, and also according to him all electrons they were static, which was not the case. So then his student, which is Rutherford, he was conducting experiments so as to prove the structure of atom, which was given by J.J. Thomson. But in that, when he conducted the gold foil experiment, what he discovered is the nucleus. So then what he said that the all the positive charge is concentrated as one place, right? All the mass is densely concentrated as the at the center, right? And he gave that center the name nucleus. And then he said that around this nucleus all the electrons are revolving around in a circular path, which are known as the orbits, right? So according to him, the electron would look something like this. So we have the nucleus at the center, which is very small as compared to the radius of the atom. And then around that we have the electrons which are moving in the circular path. Now, there were many drawbacks to this model also. So, one being that he was also not able to explain the stability of the atom. And also, he didn't say anything about the distribution of electron and their energies, right? And then after this model, which is after the J.J. Thomson and the Rutherford model, came the Bohr's atomic model. Now, Bohr, he gave his model after studying the other things, or we say the other developments that were done by other scientists. So he considered all the experiments, all the things that were taking place in the scientific community, and then he made the improvements in the Rutherford model. But before we learn about the Bohr's atomic model, we will be learning about the atomic number and the mass number, and how do we represent the atom. And if I know the atomic number and the mass number of the atom, how would I know what is the number of electron, protons and neutrons? So have you read about it? What is the atomic number and what is the mass number? So here, if I represent an element with x, then here we write the atomic number, and on the upper side we will write the mass number. So this is your mass number and this is your atomic number, which will be represented by Z, and your mass number will be represented by A. Now if I know what is the atomic number, then I can know about what will be the number of protons. So whatever is the atomic number, which we will know by looking at the element in the periodic table, right? So the atomic number of an atom will tell me about what is the number of protons, or I can say what is the positive charge. Whereas mass number will be equals to the number of protons plus number of neutrons. So your mass number will be equals to the number of protons plus number of neutrons, right? Now here, the way I will be telling you very important thing. So for a neutral atom, so if you have a neutral atom, then in that case, so this thing which I'm writing, I'll be writing right now, that will be only true for the neutral atom. This point is very, very important for you, right? That for a neutral atom, we will have number of electrons equals to number of protons, because the overall atom has to be neutral. So yes, positive charge has to be equals to the negative charge. So here number of electrons will be equals to the number of protons, which in turn will be equals to the atomic number, right? But this is only true for the neutral atom. So let's suppose if you have any ions, that is if you have a cation or if you have an ion, then in that case, we can't say that the atomic number will be equals to the number of electrons. So don't do that mistake where you are just simply keeping the number atomic number equals to number of electrons. We can only write atomic number equals to number of electrons only when we have the neutral atom, right? So from here, what we can say is, yes, if I know what is the mass number, then I know that it will tell me about the number of protons and number of neutrons. So basically, if I add the number of protons and the number of neutrons, I'll get the mass number, and atomic number will be equals to the number of protons. So from here, what we can say is that we can find out what is the number of neutrons. So from here, what I can write? Number of neutrons. So number of neutrons will be equals to atomic number minus. So from here, how we will write it? So from here, what you can see is your mass number is A, your number of protons will be equals to Z. So I can write the number of neutrons will be equals to A minus Z. So simply what you have to do is, if you are given what is the atomic number and what is the mass number, so simply what you have to do is you have to subtract the atomic number from the mass number, and that's how you'll get the number of neutrons. So if this is clear to you, which, so these are the things you might have learned in your lower classes also. So this was a quick brush up of the things that you already know. But this thing you have to specially keep in mind, which is that the number of electrons is equals to the number of proton, which is equals to the number of atomic number only. This is true only for the neutral atom, right? Keep this thing in mind that if you have neutral atom, then only you can keep the atomic number equals to the number of protons. Otherwise, we have to calculate the number of electrons by adding or subtracting the charge from the atomic number, right? So for ions, so if you have ions, right, atoms which are having some charge, so in that you can have cation and also you can have anion. So anions are the one which are having the negative charge. Cations are the one which will have the positive charge. So if you have cation, then number of electrons will be equals to the atomic number. So whatever atomic number you have to subtract the charge from the atomic number, right? For example, Na positive, right? So can you tell me what will be the number of electrons in Na positive? So quickly, so here in this class, we will be doing the calculations as small, like addition and subtraction. So sit with your pen and copy, do the calculation very quickly and write your answer in the chat. So you have to be very interactive for today and you have to constantly tell your answer in the chat box. So quickly tell me what will be the number of electrons for Na positive. So what will be the number of electrons for Na positive? Yes, Gayatri, Omkar, Bhavna, Harika. So what will be the number of electrons for Na positive? This is very easy, right? This question is very easy.
Yes, ma'am. It is 10 electrons, ma'am. In
Yes,
sodium
yes.
cation.
So we will have 10 electrons. So how did I get 10? So we know that sodium has the atomic number of 11. So here we have one positive charge. So we will subtract 1 and we will get 10, right? Similarly, you can find out what is the number of electron in O2 negative. So what will be the number of electron in O2 negative? So these are some of the basic things. So you have to be very quick so that we can finish with isotopes, isobars, isotones, right? And then we'll see few questions which you can get in your exam, which will be based on the basics. And then yes, obviously once you know the basics, then you can go to level 1 and level 2 problems. Yes, what will be the number of electrons for O2 negative?
10 electrons, ma'am.
Yes, you will have 10 electrons. What you will have 10 electrons. So what is the atomic number of for oxygen? So atomic number for oxygen is 8. Yes, so you will have 10 electrons. So now what we say see here is we have two species, which is Na positive, O2 negative, and let's take Mg2 positive. Now tell me what will be the number of electrons for Mg2 positive?
10, ma'am.
Yes, so again here you will have 10 electrons. So what you can see here is all of these species, which is Na positive, O2 negative and Mg2 positive, all of them are having same number of electrons. So the species which will are having the same number of electrons, be it the polyatomic ion or be it the monoatomic ion. It can be anything. So right now we have the monoatomic ions, right? So the species which have the same number of electrons, they will be known as the isoelectronic species. So from here, we have seen that, so this is the example of isoelectronic. These are the examples of isoelectrons. So we'll say that Na positive, O2 negative and Mg2 positive, these are isoelectronic species. Iso means same, electronic is for electron. So those are having the same number of electrons will be known as isoelectronic species. Understood? So if you have understood this, then write your definition and type yes in the chat, and then we will quickly see what are isotopes, isotones, and isobars. So the species that have same number of electrons. Okay, so you have to count the total number of electrons. Okay, don't just simply look at the charge. Correct? You have to calculate the total number of electrons, which you will be getting by doing your calculations, right? So if you are given the ions or if you are given the neutral species, so if you have the neutral species, then simply your number of electrons will be equals to the atomic number. And if you have cation or the anions, then in that case, you are supposed to calculate the number of electrons by subtracting the charge from atomic number for cations and by adding the charge to the atomic number for the anions, right? So here, what we can say is that Na positive, O2 negative, and Mg2 positive, they are isoelectronic species. Now, this is the first step, right? You may not get question related to it, but yes, question can be asked when you learn about the periodic table. They can ask you, they can give you these ions, and then they can ask you about the order of ionic radius, right? So there you should be very quick with calculating the number of electrons for that particular ion, right? So that's why these all things are very important for us to know, like how do I calculate the number of electrons as fast as possible. And also you should know what are isoelectronic species. So the species that have same number of electrons are known as the isoelectronic species, right? Now quickly calculate the number of electrons, protons and neutrons for these atoms. So here I am writing the atoms, right? So I have carbon 12, carbon 13, and carbon 14. So quickly calculate what is the number of neutron, proton, and electron. So write your answers there, and I'll also write my answer. So I'll give you 1 second and quickly write your answers here. So what we know, what we have learned is that yes, as I can see that all of them are neutral species. So yes, your number of electrons will be equals to the number of protons, right? Which in turn will be equals to the atomic number. So these will be 6, 6, and 6. Now here we have to write what will be the number of neutrons, right? So for this one, I'll have 12 minus 6, 6. Here 7, and here I'll have 8. Correct? So 13 minus 6, 7. 14 minus 6, it will be 8. So these are the number of neutrons, protons, and electrons. So what I can see here is that they have the same number of electrons and protons, or I can say they have the same number of, they have the same mass, atomic number. Whereas what I can see here is they have different number of neutrons, right? They have the different number of neutrons. So from here, what we can see is that the number of neutron is different. The electrons and protons are same, or I say the atomic number is same. whereas the mass number is different. Now in chemistry, what is the name given to such species? How are these species related to each other? So if you see this kind of a relationship between two or three atoms where the number of neutrons are different and you have the same number of electrons and protons, or we say they are having the same atomic number, then they are known as isotopes. So they will be known as isotopes. So isotopes, these are the atoms of same element. What we will say, these are the atoms of same element that have same atomic number and different number of neutrons. Now you could be asked the same statement in different ways, right? They can ask you related to the number of neutrons. They can ask you the same statement related to atomic number, number of protons or electrons, or they can ask it related to the mass number. So yes, we can write it as atoms of the same element. They are the atoms of the same element, right? Which are having the same atomic number and different number of neutrons, or I can say different mass number. So if this is clear to you, then we will move ahead with the other definitions. So if this is clear, then I'll move on to with isobars. I hope this is clear to you because these are isotopes we all have learned in 10th standard also, right? So similarly, what can be the other examples of isotopes? So yes, most of the elements in the periodic table, they have their isotopes. For example, for hydrogen, we have three isotopes, right? Hydrogen, deuterium, and tritium. So hydrogen, deuterium, and tritium. So yes, what we can see here is that the mass number is different and the atomic number is same. Similarly, what can be the other example? For oxygen also we have different isotopes. One you could be asked about is boron. So for boron also we have two isotopes. In what? In one in which we have the atomic number 10 and other one in which we have atomic number 11, and so on. You can have isotopes with other for other elements also. You can have isotopes for other elements also. Now, based on this, which is the number of isotopes, you can have other questions also where they'll be asking you to calculate the average atomic mass. Now what they'll give you, they will tell you what is the abundance of the particular isotope, right? So here what kind of a question you can get? So you can write a question, for example, so write a question, the number of three isotope of elements are the mass number. So here you are given an element and the mass number of three isotopes is 10, 12, and what else we can take? We'll take 10, 12, and 14. Now here it says that the percentage abundance, their percentage abundance is, so we'll take their percentage abundance as 80%. What else we can take? We can take 15% and 5%, right? So these are the mass number and these are the percentage abundance. So now you have to calculate the atomic weight of the element. So quickly do the so. You have to be very quick with your calculations, okay? So I'll give you 1 minute. You have to be very quick with the calculation. So calculate this. So you have to tell me the atomic weight of the element. So see what the mass that you see in the periodic table, right? Basically, that is the average atomic weight. So where you have included the mass of all the isotopes, right? That's why most of the masses that you see in the periodic table, they will be in fractions, right? It will be like something 15.0 to 35.5, 16 point something. But usually in calculation, we take the masses up to one decimal place. So yes, we usually take them as the whole number, right? But the masses that we have there is those are the average atomic masses. So there we are adding the masses of all the isotopes. Or in other words, what we can say is that they are the weighted mean mass of all the isotopes, right? Now you have to be very quick with your calculations. Also in exam, you're not supposed to use the calculator. So calculate it quickly and tell me your answer. Today now, to from today, I want answer from everyone. It's not that just one of you is replying and then others are just not responding at all in the chat. So you have to tell your answers and you have to be very quick with the calculation, because in exam also you will just have 1 or 2 minutes for doing one problem, and this particular problem, it is very simple. Now first thing you tell me, do you know how to calculate the average atomic mass, or we say the atomic mass, if you are given the abundance and the mass number of different isotopes? First tell me that. If you don't know, then I'll tell you the formula and then you can do the calculation. So yes, how many of you know how to calculate the average atomic weight, or we say atomic weight, if you are given the mass number of the isotopes and the percentage abundance?
Ma'am,
Okay,
what
you people don't know? Okay,
what is
we'll
abundance,
see.
ma'am?
Okay, okay, or this part you don't know. This you haven't learned earlier, correct? So yes, we will understand about all the things. What is abundance? What is isotopes? Okay. So see, just now what we saw is that isotopes, they are the atoms of same element, right? They are the atoms of same element which have the same atomic number but different mass number. Now let's suppose I ask you to bring hydrogen from anywhere, wherever, from whatever place. You can choose the place and you bring the hydrogen from there. Correct? Now, once you bring that hydrogen, the chances are that in that we may have the atoms of all of these hydrogens. Correct? But what will happen is, according to their percentage in nature, which is different for different isotopes, right? So let's assume that the percentage of this isotope is 90%, this is 5%, and this is 2%. So percentage abundance is how much they are existing in nature. So let's suppose here what I said is, this is 80%, this is 15%, and this is 5%. What does it mean? That it means that, let's suppose if I bring the 100 atoms of hydrogen, if I'll have 100 atoms of hydrogen, then the chances are that in that 90 of the atoms will be of this isotope, 5 atoms will be of this isotope where the atomic mass will be 2, and the two atoms will be of this isotope which is having the atomic mass of 3, right? So this is their natural abundance, the percentage in which they are existing in the nature. That means that if I am bringing this particular sample from anywhere on the earth or from outside the space, the chances are that whatever sample you have, in that you will have 90% of this isotope, 5% of this, and 2% of this. So let's suppose if I ask you to pick any one atom from this sample where you have 100 atoms of hydrogen, then if I ask Gayatri, okay, Gayatri, one atom. So she picks one atom and we'll see, okay, which isotope is that. So the chances are that the atom she might have picked is the first one. Now, why is that? Because this is the one which is existing in maximum number. This is the one which is existing in maximum number, or we can say the abundance of this isotope is maximum in nature, right? So the percentage that is given to you will tell you what is the amount or what is the percentage of this isotope that will exist in nature, right? Or you we are writing in the terms of percentage, so you can understand it in the terms of, if I'll take 100 atoms of the particular elements, then the in that 90 will be this one, 5 will be this one, and 2 will be this one. So yes, the chances that whenever you are asked to pick any atom, then the chances are the atom that will come in your hand will be this one, because this is the one which is present in the maximum number, right? So natural abundance is it is the percentage in which a particular isotope exists in nature, and most of the elements, they have their isotopic forms, but yes, the percentage it will vary, right? And the one which is present in the maximum percentage, so yes, we'll get the weight which will be more closer to that particular isotope, which you can understand by calculating the answer for this question. So here, how do I calculate the average atomic mass if I am given the atomic masses, if I am given the mass number and the percentage abundance? So how do I calculate the average atomic weight? So what you have to do is, so let's name the isotope as I1, I2, and I3, and their abundance as A1, A2, and A3. So let's suppose the abundance of first one is A1 and the isotope is I1. This is the mass number of the isotope 1. So what we have to do is we have to multiply the natural abundance with that of the mass number plus natural abundance of the other one into its mass number plus natural abundance of third one into its mass number divided by 100. So that's how you will get your average atomic mass. And what you see in the periodic table is average atomic mass, which is also in general will be known as the atomic mass. But now whenever you see the masses in the periodic table, now you know that the masses that are there are the average atomic mass, where we have considered both of these things, that what is the percentage of abundance in nature. So now quickly calculate what will be the atomic weight for these isotopes. So what will be the average atomic weight for these elements? So what you have to do here is, so is this clear to you? How do we calculate the average atomic weight? So what we will do, 80 into 10 plus 12 into 15 plus Then what else we have? This is 5%, right? 5 into 14 divided by 100. Is this clear to you? Like if you are given the mass number for the isotopes and the percentage abundance, then yes, you can calculate the atomic weight of the element, where you have to take the weighted mean average of all the masses. This is basically what we have taken. We have taken the average, but there we have considered the abundance, right? What is the abundance of the particular isotope? Is this clear to you? So if this is clear to you, then quickly, yes, Gayatri has got her answer, which is 10.5, and the calculations are quite easy, right? We don't have any complicated numbers. So this will be 800, and then you can multiply 12 into 15, and then you have 5 into 14 divided by 100, which is 10.5. Now let's see. Let's analyze this, the answer, whatever we have got. So the average mass that you have got is 10.5, right? And the isotopes that I had was having the mass 10, 12, and 14, right? And here I'll write the percentage also. 80, 15, and 5, right? Those were the percentage, right? So what is percentage abundance? The percentage in which they are existing in the nature, right? So now what we can see here is that the average atomic mass, what I am saying, what you see here is that the average atomic mass is near to which mass? So we have three isotopes. Now in that three isotopes, the average atomic mass that I am getting is near to the value 10. It is near to the value 10. Why is that? Because this is the one which is present in the maximum percentage. So if I'll take the average of all, then the mass will be towards the isotope which is present in the maximum abundance, right? So that's what you see in the periodic table. The masses that are there in the periodic table, they are basically the average atomic masses, and they are masses towards the isotope which is present in the maximum percentage. So those weight are towards the weight of the isotope which is present in the maximum abundance, which you can see by this example also. So you can note down this formula and keep it with you, because yes, you could be asked to calculate the average atomic weight. Now, there can be other questions which you can get based on this. So now here, they may give you the average atomic mass, and also they may give you the mass of the isotopes, right? So they will give you the mass of the isotope, and also they will give you the average atomic mass, and then they can ask you what is the percentage of each isotope. So shall we see the question related to that? If yes, then quickly type in the chat and I'll give you question related to this particular concept, but just a little different question based on the percentage abundance and the atomic masses. So write your question, that is naturally occurring boron, naturally occurring boron consists of two isotopes with atomic masses. So with atomic masses 10.01 and 11.01. So these are the masses of the isotope. Now in the question, you will be given the average atomic mass. So the atomic mass or we say atomic weight of natural boron is 10.81. What it is? It is 10.81. So here you have to calculate the percentage of each isotope, right? So yes, the question can be changed for calculating the percentage abundance. So instead of asking you about the average atomic mass, they may ask you about the percentage of each isotope, right? So this you have to do. Now there is one thing I want to tell you is, see, there are two things. What is that? You have the average atomic mass and you have the isotopic mass, right? You have the mass that is for the isotopes, right? So in chemistry, the masses that you see there in the periodic table, those are the relative atomic masses. That is the relative atomic mass. So whatever masses that we see on the periodic table, those are the relative atomic mass, and this we have learned in mole concept also, that all the masses, they are taken with respect to the mass of 1 by 12 into mass of carbon 12 atom, right? Which we then wrote as AMU, right? Which we then wrote as AMU. So now here, as in this question, it is saying that one boron isotope has the mass of 10.01 and other boron has the mass of 11.01. So whatever masses that you see, they are relative masses with respect to this. Why did we do that? This we have learned, right? Because we want to simplify our calculations. Every time we won't write the masses here, because the masses will be in the powers of 10 raised to the power minus 27, 31 kg, right? So every time I won't write that big value. So what we did is we took the relative masses. So these are the isotopes of boron. So the name, these masses will be known as relative isotopic masses. So these will be known as relative isotopic masses. Now, when I consider the percentage abundance and the masses of these isotopes, and I take the weight of these isotopes by using this formula, then the masses that I'll get is the relative atomic mass, which will also known as, so simply you can write it as atomic mass, or we say average atomic mass, right? So this is the weighted average mass, right? Or we say weighted mean mass. So basically we are taking the mean here, right? We are taking the average, but we are taking the weighted average, means we are considering what is the abundance of each isotope in the nature, right? So that's what we mean by weighted mean. So here we are considering what is the abundance, because then the one which is more in the percentage in the nature, the total mass will be more near to that isotope. So these things should be very clear in your mind, that if I say, okay, these are the masses of the isotope, then we say these are the relative isotopic masses. Now, considering the percentage abundance and the relative isotopic mass, I'll calculate the relative atomic mass. So what you see in the periodic table, they are the relative atomic masses. They are not the individual isotopic masses. I take the weighted average of the isotopic masses and then I get the atomic masses, right? Is this clear to you? That whatever we have in the periodic table, these are the relative atomic masses, and all these things you might have learned in the lower classes, but just I gave you the quick revision. Understood? I hope this thing is clear to you. You should know, like behind, whenever you are seeing any numerical, whenever you see any mass, then you should know that, okay, in the back of your head, you know, okay, the mass that I am seeing, it is the weighted average. And the term that you will be using will be relative atomic mass, average atomic mass. All of the three things are same. Whereas the masses of the individual isotope will be known as the relative isotopic masses. That's why this is not the word that you are using very often. Correct? Because the masses that you see in the periodic table, they are not for the particular isotope. They are the average masses of the all the isotope that would exist for the particular element. So all these things should be clear, right? So if this is clear to you, then you will have to calculate what is the percentage of this and this isotope for boron. So this is your homework question which you have to do. This is your homework question which you'll have to solve. And make sure that each one of you send your answer in the group, right? So sit there, look at this formula, substitute the values. So what are the things that we have? We have the average atomic weight, we have the masses of the isotope. The only thing that you have to calculate is the percentage abundance. And yes, it is saying, so here I wrote for 3 isotope because in question it was saying that for the particular element we had the 3 isotope. So but for this question you just have 2 isotope. So yes, from there you will calculating, you'll write the formula for the 2 isotopes and then see what are the things that you know and what is it that you have to calculate. So now the percentage abundance for one you can take as x. So it is percentage. So for one, if you are taking x, then for the other one you will be taking 100 minus x. So I have given you the hint. You have to do the calculations and then you will have to send your answers for this question. So is this thing clear to you related to the atomic average atomic mass? Now you should know that the masses that you are seeing in the periodic table, those are the average atomic masses, right? I am repeating this again and again because this is a very important concept, that what the masses that you see, the masses that you are using, they are the average atomic mass, and that's how you calculate the average atomic mass. That is, you consider the percentage abundance, you multiply it with the atomic masses, and then you take the average. So if this is clear to you, then we will learn about the isobars. So we will learn about the isobars. So now you calculate the number of protons and neutrons for argon, and we will take potassium and we will take calcium. What we will take? Calcium. So calculate, so electrons, protons and neutrons. So quickly calculate these values. If you have any doubt in the percentage abundance or about the atomic masses, you can ask it. Okay, you can ask your doubts. We still have 5 minutes and we'll quickly see isobars. If you will find your answers, we can see what isobars are. So what is the number of protons here? So proton, simply if I see the atomic number, I can write this is 18, 19 and 20. Now tell me what will be the number of neutrons. So this is 22,
Ma'am,
21 and
20.
20, right? Now what is the number of electron? It will be same as the number of protons because these are the neutral atoms, right? Now here we can see nothing is same, right? Neither proton is same, neither neutrons are same, neither the electrons are same. Now let's come to the atomic number. These are also not same. But yes, what I can see here is that they have the same mass number. So what? How will I write the definition for iso? Bars. What I am seeing? Isobars. So they are the atoms of different element. This particular statement is very important, that they are atoms of different element. Whereas in isotopes, what we were writing, they were the atoms of same element. Here, isobars, they are the atoms of different element that have same mass number and different number of protons and neutrons. Now you might be wondering, how would I get the question based on this? So yes, you can get the question in terms of statement. They'll give you 4 statements where they'll give you, okay, isobars are the atoms of different elements which have the same mass number and different number of protons and neutrons. Yes, that statement would be correct. So now they'll give you 4 statements, and among those 4 statements, they may say you what is the number of statements that are correct, right? So along with that, they can give you some other statements also. So these words are very important, that they are the atoms of different elements which have same mass number but different atomic number. Or if they don't want to write it as different atomic number, what they will write is they will have a different number of protons and neutrons. So yes, you have to know the definition in terms of number of protons and neutrons. So so for the isotopes, what did we have? So for isotopes, what was it? That was same. So in that, we have the same number of protons and electrons, and the number of neutrons were different. Or else the other way of saying it is that they have the different mass number but they have the same atomic number, but the things are different in isobars. So be very careful with the definition and what is given in the question. So if this is clear, then finally we have to see isotones. So isotones, these are also the atoms of different element. They are the atom of different elements that have same number of neutrons. That have same number of neutrons. So here you can have the example of silicon, phosphorus, and what else we can take with this? Sulfur, right? We can take sulfur 32. So now you'll have to calculate what is the number of neutrons. And once you calculate the number of neutrons, you will see that they have the same number of neutrons. So basically here today we saw what is isotopes, isobars and isotones. Yes, you could be asked about their definition in form of statements. And also we saw that how do I calculate the average atomic mass if I am given the percentage abundance of these isotopes. And this is a very small topic but a very important topic from exams perspective, right? Also, there is one more question, you can write it as homework, which is you will have to give isobar, isotone and isotope for give it for carbon 14. Give it for carbon 14. Okay. So you will have to give example of isobar, isotone and isotope for carbon 14, and this is your homework. So you have 2 questions as the homework, which is where, yeah, this question And also you have to give the example of isobar, isotone, and isotope for carbon 14, which is one of the isotopes of carbon which does not exist in that much of the abundance. So the only isotope that is present in maximum abundance for carbon is carbon 12, and the abundance is around 99.09%. That's why the carbon 12 is taken as the reference, because yes, the other isotopes for carbon, they are not present in that much of the abundance, so the chances of error is very less, whereas for the other elements the abundance of the isotopes are is significant in number. So then there will be lot of discrepancies in the calculations, right? You will be having problems in the calculations. So yes, this is the other reason that carbon was taken as the reference, because here the carbon 12 has the maximum abundance. So in all of its isotope, which is 12, 13, and 14, carbon 12 is present in the maximum abundance of around 99%. Then you have other two isotopes. Okay, so I hope this topic is clear to you. Now, in the next class, we will start with the developments that led to the Bohr's atomic model. So we'll start with learning about the electromagnetic radiations. So I hope this is clear to you. So if this is clear to you, we'll end this session and then you can continue with your classes. Yes, Chandrika ma'am.
Yes, ma'am. Thank you, ma'am.
Yeah.
Yes, students. Neet students, you can leave the meeting. Neet students, you can leave the meeting. And all the IIT students should be present. Now I would invite Kevin sir to start the session.
Good morning, dear students. Just share the screen for you.
Wait for a few seconds, students. I think sir has some technical issue. Yes, students, please wait for a minute. Sir has joined.
Is the screen visible to everybody?
Yes, sir, it is visible, sir.
Okay. Dear students, yesterday I had given you a homework. Did you solve the problem? Or did you find any difficulty in solving the problem? What answer did you get, dear students? The problem that I gave as a homework was find the value of sine 50 degree minus sine 70 degree plus sine 10 degree. Will you solve this problem, dear students? What value did you get? Students, dear students, did you solve the problem? Can you one of you respond, dear students? Can you unmute your mic and respond?
Yes, sir, we didn't got this answer.
What is the answer? What is the answer? What was the answer you got, dear students?
0.
0. Very good. So just we'll do it once again. So we use the formula of sine of x minus y as sine c minus sine d. That will be giving me what? Sine 60 into cos 10 minus minus of cos 60 into sin 10. Minus is there. I am taking minus as it is. Then it comes as again sin 60 into cos 10 minus. So formula for plus is plus has to come plus into minus again it becomes minus. So it becomes minus cos 60 into sin 10 plus sin 10. So here this plus sin 60 cos 10 and this minus 60 cos 10 get cancels. What we are left out will be minus, say minus 60 sin 10 minus 60 sin 10 will become minus 2 cos 60 sin 10 plus sin 10. This will give me what? Minus 2, that is the value of cos 60, 1 by 2 into sin 10. I don't know, I'm keeping as it is sin 10 plus sin 10. 2 to get cancelled, so minus 1 into sin 10 will give me minus sin 10 plus sin 10. So both minus sin 10 and plus sin 10 get cancelled and I get my value as 0. Okay, now we'll solve the next problem. The problem is, it is displayed on screen here. The Find the value of sine minus 4 to 0 cos sine. Find the value of sine of minus 420 into cos 390 plus cos of minus 660 and sine 330. I'll give you a clue, students, how to proceed ahead. I told last time itself why we are studying ASTC rule as all silver teacups. That is to reduce the greater angles to smaller angles. So here all our angles are big. So we'll be using ASTC rule to simplify these angles. So this will give me what? Sine of, first of all, I simplified, I write it as minus sine for 420 degree into cos 390 degree. Cos of minus theta. Cos of minus theta will give me what? Plus cos theta. So plus cos 660 degree into sine 330 degree. This is equal to. This is equal to. I'm giving minus as it is. Sine 420 can be expressed as. Can I write it as sine 360 plus 60?
Yes, sir.
So I can write it as sine 360 plus 60 into cos also. I can write it as cos
360.
of 360 plus 30 plus again cos. I can write it as, how I can write it as, can I write it as 720 minus 60 and again sine into sine 360 minus 30. Did you all understand this step, dear students? So now, coming back to ASTC rule. In ASTC rule, yesterday we learned two important rule or two important notes to be remembered. What are those things? If my angle is pi by 2, 2 pi by 2, sorry, if my angle is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on. To say generally, if my angle is 2n plus 1 pi by 2, then my trigonometric functions will change. And if my angle is pi, 2 pi, 3 pi, 4 pi, my angle will not change. So sine 360, that is what? Sine 2 pi. Will my trigonometric function will change? No. My sine 360 will remain as it is. So sine will remain sine. 360 plus theta, which quadrant the angle is going to come? So this is 90 plus theta. This is 270 plus theta. So this here you will get 360 minus theta. That is one round is over. So we can take as an example. Let us say all of you have been to your sports meet in your school days. There we have a lot of track events. And some of the track events that some students participate is 1400 meter, 1800 meter, etc. So when we participate in those track events, the maximum perimeter of the ground may be a 400 meter or 500 meter. But you want to run 1400 meter, 1800 meter. How is it possible? You have to run in the ground maybe some 3 or 4 rounds. Then Rest you have to complete some 100 meter or 200 meter to the straight line. So same thing is happening. My angle is completed one round here, 360. And still, let us say let us say this is my school ground. Imagine, and you are running a track event. The perimeter of this circle, the track event that you are going to run, maybe let us say some 400 meters. And the event that you are partaking is 1400 meters, let us say. So for 1400 meters, you have to run 3 rounds. Sure. Once you run 3 rounds, you complete 1200 meters. To do extra 200 meters, what you do after reaching some point here, you have to run some straight 200 meters. Isn't it? The same thing is applied here for the angle. Now my angle has to go 420 degree. So my angle is completed 360 degree till here. Now it is running a straight track of how many degree? 60 degree. So the side when the angle is running the straight track of 60 degree, my angle is coming to which quadrant? My angle is coming back to first quadrant. So what, in first quadrant, what happens? All the trigonometric functions are positive. Therefore, I take sine as sine 60 with positive sign. Plus into minus will become minus. Did you understand this concept? Yes, I took minus t. Student, is this clear? Now coming back to
Yes.
cos of 3. Now coming back to cos of 360 plus 30. Again, my angle is completed 360. It is coming. It has to run a little extra mile. That is 30 degree. So my angle is coming back to first quadrant. Since 362 pi is there, cos will not change. Cos will remain as cos. So it becomes 30 degree and the sign will be positive because first quadrant all are positive. Coming back here. Cos of 720 minus 60. So one round is 360. Second round is 720. So 2 rounds are over. But what is happening when we run for long track events, let us say 1400 meters or 1800 meters, some students complete the race, some they get tired and they give up, or some they fall down in the track. You have noticed all these things. So same thing is happening for this cos angle. What happening? The cos supposed to complete 720-meter race. It is trying to complete, but somewhere before completing 720 race, it has fallen down. So how much more it has to complete? It has to complete 60 more meter. But before completing that 60 meters more, my this cos is falling short. It is getting fainted and falling down. So my cos is not completing 720 degree, rather somewhere in between before 720 degree, it is falling short. So what happening? 720 minus 16. So see, before complete, my 720 will be here. Before completing 720, it is somewhere it is falling short. So it is in which quadrant? Fourth quadrant. Fourth quadrant, cos is positive, and 720 is what? It is 4 pi. So multiple of pi. So cos will remain cos. And fourth quadrant cos is positive. I take plus sign cos 60. Just a minute. Into same thing. The sign has to complete one round. Before completing the round, the sign is falling short. It is sprinting and falling. So it is printing and following before completing. So it is some, if it is, if you would have completed 30 more degree, if you have completed the one complete round, but somewhere here it is falling down. So my sign is coming to which quadrant? Fourth quadrant. Fourth quadrant sign is negative, so I'm taking negative sign. And 360 is a 2 pi. That means my angle sign will remain same, will not change sign. The angle is 30 degrees. Do you understand this step, dear students? I got it in the step what we did using ASTC rule. Students.
Yes, sir.
So then we know all the values of this one. So these are all standard values. So I have to apply the standard values. So what will be my standard value now? Sin 16 is minus root 3 by 2 into cos 30 means again root 3 by 2 plus 1 by 2. This minus I'll take it here. So this will become minus. So 30 will be again 1 by 2. If you simplify root 3 into root 3 whole square. So square and square root get cancels. Minus 3 by 4 minus 1 by 4. If you do this one, 4 is LCM. So minus 3 minus 1, that will give me minus 4 by 4. Simplify. What am I getting as answer? I'm getting answer as minus 1. So what is the value of sine minus 420 cos 390 plus cos of minus 660 to sine 330? The value is minus 1. Do you understand this problem, dear students?
Yes, sir.
Okay. Now, since we are dealing with IIT and JEE mains, I told already we are learning few formulas like what we learned already. The formulas that you know is sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cosecant square theta is equal to, sorry, 1 plus secant square theta is equal to cosecant square theta. Sorry, cot square theta is equal to cosecant square theta. And yesterday also we learned some 6 formulas like cos of a plus b, cos of a minus b, sin of a plus b, sin of a minus b, tan of a plus b, tan of a minus b. Okay, this is part of your board level syllabus. We are learning it. For IIT, we need to learn some more formulas. Why means to make our problems to solve easily. We can't spend for one problem some 10 minutes in the exam because then we can't attend all the questions. So as a result, for IIT level itself, we learn some extra formulas to make our problems to solve our problems easier in shorter time. So in that regard, today I will be teaching you important formulas which will help us to solve our problems easily. So I am sharing my screen here. See here in the screen already first formula you know it. Sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. So 1 plus cot square theta is equal to cosecant square theta. So far it is okay. Now comes sin square theta plus cos square theta is okay. What about sin to the power of 4 theta and cos to the power of 4 theta? Formula for that one is 1 minus 2 sine square theta into cos square theta. Sine to the power of 4 theta into cos to the power of 4 theta is equal to 1 minus 2 sine square theta into cos square theta. Similarly, for sine cube theta, sorry, sine to the power of 6 theta into cos to the power of 6 theta. So theta has to come here. A mistake has happened. That will be give me as 1 minus 3 sine square theta into cos square theta. Dear friends, please write this, what is this called as formula somewhere in one place and learn it, because these formulas will help us to solve the problems easier and reduce our time. Another important formula that we'll be learning in this regard is these two formulas. We'll be using these formulas very often in solving the problems. Secant theta minus tan theta. The formula for secant theta minus tan theta is equal to 1 plus secant theta plus tan theta. Secant theta minus tan theta is equal to 1 plus secant theta plus tan theta. Whereas cosecant theta minus cot theta is equal to 1 plus cosecant theta plus cot theta. Cosecant theta minus cot theta is equal to 1 plus cosecant theta plus cot theta. With this, you'll be learning this one also. Sin theta into sin 60 minus theta into sin 60 plus theta. So when you have product of sin theta into sin 60 minus theta into sin 60 plus theta, then the answer is 1 by 4 sin 3 theta. If you have product of sin theta, sin 60 minus theta and sin 60 plus theta, then the answer will be 1 by 4 sin 3 theta. Similarly, cos theta into cos 60 minus theta into cos 60 plus theta. This will give me the answer as 1 by 4 cos 3 theta. We got to tan theta plus tan 60 minus theta into tan 60 plus theta. This will give me tan 3 theta. So we'll be using these important results or important formulas to solve our problems and to simplify it. Did you take notes, students? Then basing on these formulas, now we will solve some problems. The next question we want to solve is, if secant x minus tan x is equal to p, then secant x is equal to, then what is the value of secant x? They're telling that if the secant x plus minus tan x is, if the value is p, find me the value of secant x. Students, I want you to try this problem. Please use the formula what we learned just now and tell me the value of secant x. I'll give you 2 minutes. Actually, not even 1 minute is required, but I'll give you 2 minutes, dear students. Use the formula of what we learned and tell me the value of secant x. Is it okay, dear students?
Sir, is that 1 plus tan square theta under root?
No. Use the formula. We learned the formula now. What we learned the formula? Secant x minus tan x is equal to 1 by
Secant x plus
secant x plus tan x. Use this formula. Use this formula And what I could do is you find the value for secant x minus tan x and find the value for secant x plus tan x and add those equations. I'm giving you one more hint now. You find two equations. You find the value, first you find the value for secant x minus tan x. Already they are given. Next step, you find the value for secant x plus tan x. You get two equations, then add those two equations and simplify those equations. You will get, okay, you will
1
get
by
one,
P.
1 by p, but I want the value of secant x. Okay, you're finding difficult. Okay, let me help you out. So they already given me secant x minus tan x is equal to p. I keep this as equation 1. Now I know the value of secant x minus tan x is equal to p. P is equal to 1 by secant x plus tan x. Therefore, secant x plus
Sir, I got the answer, sir. P square plus
what is
1
the answer?
sec, sec,
Pardon?
secant x is equal to
I know
P square
you
plus 1 by P, sir.
p square plus
1 by P.
1 by p
Minus tan x.
no. So this will give me what my secant x plus tan x will be equal to. So I want this value. So cross multiply. This will become 1 by p. Correct. So this is my. I'll add my equation 1 and 2. So my equation 1 is secant x minus tan x is equal to p. Secant x plus tan x is equal to 1 by p. So what happens? 2 secant x minus tan x plus tan x will get cancelled. 2 secant x is equal to p plus 1 by p. This will be equal to what? If I take LCM, this will be p square plus 1 by p. But I want only secant x. Secant x is equal to p square plus 1 by 2p. A student, you told your answer p square plus 1 by p is correct, but I want the value for secant x, so that 2 has to be sent down. Did all get this answer? Did all understand this problem? So one student who has done that one is a good way, but you forgot to send the value 2 down, correct?
Yes, sir.
So please be little vigilant in these smaller things. There you lose mark. So once all these things, all the like this, we call them as integer type questions. They won't give you options for these questions. They'll give you like fill in the blanks questions, and each question will carry 4 marks. Any small mistake of this sort, you will lose 4 marks. That's the reason. So for your exams, it will be like multiple choice as well as integer type questions. So that time you have to be careful, especially when it comes to integer type questions. Then we solve the next problem. So if alpha plus beta is equal to pi by 4, then the value of 1 plus tan alpha into 1 plus tan beta is equal to dash. That telling if alpha is equal to alpha plus beta is equal to pi by 4, then the value of 1 plus tan alpha into 1 plus tan beta is equal to dash. How can we solve this? Any idea, dear students? Somewhere getting some idea? You want to find the value of 1 plus tan alpha, and you have to find out 1 plus tan beta. Somewhere something is clicking in your mind. No issues. So I'll take the given. What is given? Alpha plus beta is equal to pi by 4. What I will do is, I'll take tan on both the sides. I take tan on both the sides. It becomes tan alpha is equal to tan of pi by 4. So now I have got the formula for tan B in the left hand side. Right hand side, I got the value for tan pi by 4. So using this, I'll simplify the equation. So if I simplify, it will be tan alpha plus tan beta whole divided by 1 minus tan alpha into tan beta is equal to, what is this value? 1. Cross multiply, I'll cross multiply. What happens? By cross multiply, it becomes tan alpha plus tan beta is equal to 1 minus tan alpha into tan beta. What I will do is, I'll send this minus this side. So what happens? This one, this will be is equal to tan alpha plus tan beta plus tan alpha into tan beta is equal to 1. So keep this as equation 1. Now there is something we have to find out. What do you have to find out? You have to find out the value of 1 plus tan alpha into 1 plus tan beta. So what do you have to find out? We have to find out 1 plus tan alpha into 1 plus tan beta. So what I will do? I will do multiplication. 1 into 1, 1. 1 plus tan beta, it is tan beta. Plus tan alpha plus 1, tan alpha. Sorry, tan alpha into 1, tan alpha. Plus tan alpha into tan beta, tan alpha into tan beta. So 1 plus, see here, tan alpha plus tan beta into tan alpha into beta has got a value here. Tan alpha plus tan beta plus tan alpha into beta is equal to 1. I'll put that value here. See, I'm getting the same thing here. Tan alpha plus tan beta plus tan alpha into tan beta. The value is how much? 1. So 1 plus 1 is equal to 2. So what is the value of my 1 plus tan alpha into tan beta? The value of my 1 plus tan alpha into tan beta is equal to 2. Do you understand this problem, dear students?
Sir, can you explain again, sir?
Okay.
Second step I didn't understand, sir.
So the given condition is equal to 5 by 4. So I have no any other option to proceed. So I take a given condition. What I will do is, I will take, let us say, I will take it as tan. I'll take both the sides tan. So it becomes tan alpha plus beta is equal to tan pi by 4. For left hand side, formula to use. For right hand side, I have got a value. So no issues. So I can simplify and go. So what I'll do for left hand side, I will use the formula. Formula is equal to tan of A plus B will give me what? Tan A plus tan B whole divided by 1 minus tan A into tan B. Basing on this one, I'm simplifying on my left hand side. So it becomes tan alpha plus tan beta is equal to 1 minus tan alpha into tan beta. Whereas my tan pi by 4 is equal to 1. So I'll do cross multiplication. So what happens? This will go here, and it is 1 year, no problem. So tan alpha plus tan beta is equal to 1 minus tan alpha into tan beta. So I want to send this minus this side. So what happens? Tan alpha plus tan beta plus tan alpha into beta will become 1. So the value of so much will become 1. I keep this as equation 1. But in the question they've asked us to find out the value of 1 plus tan alpha into 1 plus tan beta. What I 1 into 1, 1 plus 1 into tan beta is equal to tan beta plus tan alpha into 1 is equal to tan alpha. Tan alpha into tan beta is equal to tan alpha plus tan beta. See here, 1 I am written as it is, but I got the value for the entire thing here. What is this here? Tan alpha plus tan beta plus tan alpha into beta, I got a value. Tan alpha plus tan beta plus tan alpha into beta, I got a value. What is the value? 1. I'm substituting the value for this entire thing, 1. That will give me 1 plus 1 is equal to 2. Do you understand?
Yes. Yes, sir.
So we'll go to next problem of same type, but I want you students to solve it. And, next problem is of almost a similar. Next problem is almost similar type, but I want you. So the question is, if sine alpha is equal to 3 by 5 and cos beta is equal to 9 by 41, and both my alpha and beta are on first quadrant, find sine alpha minus sine beta. So first of all, what is the formula for sine alpha minus sine beta? Tell me the formula. Sine alpha minus sine beta is equal to sine alpha to cos beta minus cos sine beta. This is the formula.
Now
To
your
find
voice
the
is
value
not
of
clear.
sine alpha. Okay, okay.
So your voice is not clear.
Is it okay, dear students?
Yes, now it's fine, sir.
Okay. So now there is we have expanded the formula. Sine alpha minus sine beta is equal to sine alpha into cos beta minus cos alpha into sine beta. So if I want to find the value of sine alpha minus beta, I want the value of sine alpha. I also need the value of cos beta. I also need the value of cos alpha and sine beta. But what they given is only sine alpha and cos beta. So let's find the value of cos alpha and cos beta, sorry, sine beta, and substitute it in the value, the and in the formula, and we'll get the value. We try it out as a homework, dear students. Students, will you try it out as a homework? Hello, students.
Yes, sir, will try.
Okay, you can do it in many ways. You can use identity and you can do it. But I'll try, I will recommend you to use trigonometry, Pythagoras theorem. More than Pythagoras theorem, use Pythagorean. I will come across this concept called as Pythagorean triplets. Pythagorean triplets. I heard about this concept, Pythagorean triplets.
Yes, sir.
Give me one example for Pythagorean triplets.
Sir, 2, 3, 5.
2, 3, 5. Next. One more.
3, 4, 5.
5, 12, 13. Understood? No. So basing on this Pythagorean triplets, please do it, because that will also reduce the time. That will also easily help us to find the value, because we know that sine is opposite by hypotenuse, whereas the cos is adjacent by hypotenuse. So if it is 5 means this will become 3 by 5.
Sir, your voice is cracking.
I think because of just one minute.
Sir, your voice is not clear, sir. It is cracking.
Is it okay now, dear student?
Yes, sir. Now it is okay, sir.
Okay. So now we are going to solve this question. So we will do this as a homework, dear students. Students,
Yes, sir.
okay. Now we'll go to the next problem then. Next problem is a little easier one and interesting one. Let us see how we are going to solve it. Ah. The next problem is secant. So the question is very simple. Let's listen. So the question is secant to the power of 4x minus cosecant to the power of x 4x minus 2 secant square x plus 2 cosecant square x equal to 15 by 4. Find tan x. So let us try to solve this problem. So consider given equation. What is the given equation? Secant to the power of 4x minus cosecant to the power of 4x minus 2 secant square x whole square x is equal to 15 by 4. So what do
Sir, your voice is not
we
clear.
are here as to now dear student,
Students, please wait for a few seconds. Maybe sir is facing some network issue.
Is it okay now?
Sir,
Yes, student.
sir, your voice is cracking, sir.
Hmm.
Sir, can you please check the network? Internet. Yes.
Just a minute, ma'am.
Okay, sir.
Is it okay now, ma'am?
Yes, now it's okay, sir.
Because they drizzling. There's one.
Okay, but again it is repeating, sir.
Again, it is getting voice. Chandragana, again, the voice is breaking.
Yes, sir. Yes, students, I hope all of you know about scholarship exam that is going to be conducted on this Sunday, July 14th, right? So please inform your friends. This time we are going to select 80 students. Pass the information to your friends and encourage them to register. Yes, sir.
Ma'am, can we call off the class today for time being? I will, because here also the climate is little drizzling also.
Okay.
Sorry for the inconvenience caused, ma'am. Shall we call off the class for today?
Yes, sir. That's okay, sir. Yes, sir. We can end the class.
Kindly solve the problem of what we learned today, the homework problem, and we'll discuss this problem tomorrow with further details. Uh, and sorry for the inconvenience caused because of this network issues.
Yes, sir. That's okay, sir.
So thank you one and all. Students, one request from my part is kindly go through the new formulas what you learned, not which is not part of your syllabus or board exams, but that will be helpful if you are preparing for IIT. So as a result, I'm requesting you from my side is to learn these new formulas and write it somewhere where you can find it easily. Well, still in trigonometry, there are a lot of new formulas that you're supposed to learn for IIT. As we proceed with the classes, I'll be giving little by little. I don't want to burden everything in one day. So little by little, I'll be giving some formulas. Kindly do take note of these formulas in one side and learn it. Thank you one and all.
Yes, sir. Thank you, sir. Yes, students, please don't forget to do the homework, whatever sir has said. And also, please forward about the scholarship exam to your friends. Tomorrow is the last date. Sorry, actually today is the last date. Today evening is the last date to submit the response and get registered. This time we are going to select 80 students, so please kindly forward to your friends and encourage them to join. Encourage them to register. Bye everyone. Again we'll meet in the evening from 7 to 9. As you know, the classes have been splitted. So 7 to 8 one link and 8 to 9 we will forward another link. Bye everyone and have a good day.